Welcome to the Astro Guy podcast. I'm your host, Wayne Zool, and May is here along with warmer evenings, blooming landscapes, and some incredible sights visible on May evenings. This month, we'll see what planets can be seen, take a look at a spectacular lunar feature, explore a meteor shower with its roots in Halley's Comet, and we'll guide you through one of the sky's most underrated constellations. So whether you're an experienced observer or just getting started, there's something in this episode for you. So let's get started with our Planetary Roundup. As May begins, you'll be able to enjoy a couple of planets just after sunset, but most of the action takes place in the morning skies. Mercury will be visible low in the eastern skies as May begins. On the 1st, the innermost planet will rise at 5:07 in the morning, and will be glowing at magnitude 0. You'll need an excellent eastern horizon binoculars or a telescope to pick it out of the twilight glow. By the 3rd week in May, Mercury will be very low, making it too difficult to see. Venus, on the other hand, is easy to spot and is well placed for early risers in May. On the 1st, Venus rises at 4:12 in the morning, and is glowing brilliantly at magnitude minus 4.74. The planet appears as a 30% illuminated crescent, nearly 30 arcseconds wide. By the end of May, Venus rises at 3:25 in the morning. It's slightly fainter at magnitude minus 4.4 and is now showing a 49% illuminated crescent and spanning 24 arcseconds across. On the morning of the 23rd, look for the 19% crescent moon about 6.5 degrees above and to the right of Venus. The next morning, an 11% crescent will appear a little more than 7 degrees to the left of Venus. Mars is currently the standout planet in the evening skies this month. On the 1st, it is glowing at magnitude 0.9, and its disk is now a little less than 7 arcseconds wide, making spotting any features on the planet difficult. It spends most of the month in Cancer before moving into Leo on the 25th. By the end of the month, the red planet will have faded to magnitude 1.2 and will appear to have shrunk to less than 6 arcseconds wide. On the evenings of the 2nd through the 6th, you can watch the planet glide past the large, bright open cluster known as the Beehive, or M44. The nearly first quarter moon will join the scene on May 3rd. This should be a real treat to see in binoculars. Jupiter spends the entire month in Taurus. On May 1st, the largest planet in our solar system is glowing at magnitude minus 2 and spans 33 arcseconds across, and the planet sets a little after 11 p.m. By the end of May, Jupiter will have dimmed slightly to magnitude minus 1.9 and will appear just over 32 arcseconds wide. Jupiter is now setting at 9:40 p.m., so May and early June will be our last opportunities to see Jupiter until it returns to the morning skies later this summer. On the evening of the 28th, the thin 2-day-old crescent moon will be just over 7 degrees above Jupiter, low on the western horizon. Binoculars will help you pick them out of the twilight glow. Saturn is in the morning skies in Pisces all month long. On the 1st, rising at 4:21 a.m., the ring planet is shining at magnitude 1.1, low in the eastern pre-dawn skies. The disk of the planet spans about 16 arcseconds, while with the rings it's nearly 37 arcseconds wide. However, the rings appear nearly on edge, so this will be an unusual looking Saturn. By the end of May, Saturn rises at 2:26 a.m. and is slightly brighter at magnitude 1. Its size hasn't noticeably changed. On the morning of the 22nd, the 30% illuminated waning crescent moon joins the scene, appearing just over 4 degrees above and to the right of Saturn. This should be beautiful with the naked eye and binoculars. Uranus is too near the sun in the sky to be seen this month. As May begins, faint Neptune can be found about 3 degrees to the left of Saturn. The planet is dimly glowing at magnitude 7.8 and spans a little more than 2 arcseconds wide. Its brightness and size won't noticeably change, But by the end of the month, Neptune will appear about 1.5 degrees away from Saturn, making the pair visible in some telescopes at low power. Last month, a new comet graced the morning skies. Comet C2025 F2 Swan was discovered in late March with the Solar Wind Anisotropies instrument called SWAN on NASA's Solar and Heliospheric Observatory, or SOHO spacecraft. The comet, which had brightened in April, didn't quite reach naked eye visibility. On May 2nd, the comet will make its closest approach to the Earth at a distance of 0.96 astronomical units, or 144 million kilometers, roughly 90 million miles away. However, as I record this, it appears that the comet may already have broken up. It's possible that southern hemispheres may have a shot at it, but it's not looking very good right now. I'll leave a link in the show notes where you can get more information about the comet for your location. April nights can see the peak of the annual Eta Aquariids meteor shower, which peaks on the night of May 5th into the morning of the 6th. While the moon will be just past first quarter, it will set before the radiant is very high in the sky, so late night into early morning will be your best times to try to spot any Eta Aquariids. These swift-moving meteors produce persistent trains of debris on a good percentage of the ones entering the atmosphere, making this a fun shower to observe. Observers should expect to see between 10 and 30 meteors per hour, with possibilities of up to as many as 50 per hour. These meteors are produced as the Earth passes through a trail of debris left behind by Halley's Comet. Here's a quick space mission update. On March 31st, SpaceX's Fram-2 mission made history as the first human flight to orbit Earth over both poles. Launched from the Kennedy Space Center aboard the Crew Dragon Resilience, this privately funded mission was led by cryptocurrency entrepreneur Chun Wang and included a diverse international crew with members from Norway, Germany, and Australia. Over nearly 4 days, the crew completed 55 orbits, each passing directly over the North and South poles, offering unprecedented views of the Earth's polar regions. The mission's science objectives were equally groundbreaking, featuring the first human X-ray taken in space, studies on muscle and bone preservation in microgravity, and experiments in cultivating oyster mushrooms aboard the spacecraft. Fram-2 provided stunning imagery and data from some of the planet's most remote areas and was a big step in private space exploration.
Now it's time for the
Lunar Feature of the Month. This month, we're highlighting one of the moon's most distinctive craters, Schiller. Named for Julius Schiller, who was born in 1580 in Augsburg, Germany, Schiller worked as a lawyer and worked closely with his colleague Johann Bayer. In 1627, just prior to his death, Schiller, with Bayer's assistance, published the star atlas Caelum Stellatum Christianum, which substituted the pagan names of constellations with biblical and early Christian figures. Specifically, Schiller replaced the zodiacal constellations with the 12 apostles. The northern constellations were made up of figures from the New Testament, and the southern constellations by figures from the Old Testament. Needless to say, Schiller's version didn't catch on, but he is immortalized with this unique crater on the moon. Unlike the typical round or slightly elliptical craters we see all over the moon's surface, Schiller is elongated, almost like a smear across the moon's face. It's about 111 miles, or 179 kilometers long, and just 44 miles, or 71 kilometers wide, giving it a stretched, oval appearance that jumps out even in binoculars. But why is it shaped like this? The most widely accepted explanation is that Schiller was formed by a low-angle impact, likely by a meteoroid that came in almost parallel to the surface and gouged out this long scar of a crater. This kind of glancing blow doesn't create the usual circular shock wave. Instead, it results in something like a trench. The other explanation is that Schiller was formed by two old craters that fused together over time. The best times to observe Schiller are when the moon is between 9 and 11 days old, when the lunar phase is a waxing gibbous moon. At this point, the morning sunlight strikes the region at a low angle, casting long shadows that really accentuate Schiller's unusual shape. You can find it in the southwestern quadrant of the moon, near the moon's limb. While it can be glimpsed in binoculars, it's much easier to observe in telescopes at 50 power or higher. Under good seeing conditions, you'll see that the floor of Schiller is relatively flat and lined with a narrow ridge that runs nearly along its length, almost like a spine. The walls are worn and somewhat slumped, indicating that the crater is very old, likely more than 3.9 billion years old. If you're into lunar imaging or sketching, Schiller is an amazing subject. Its shape is so unique that it grabs attention immediately, and it's fun to track how its appearance changes under different lighting angles across the month. So the next time you're out observing a waxing gibbous moon, spend some time exploring Schiller. You'll go back to it again and again. Now, let's turn our attention to the small, unassuming constellation Comet Berenices. Nestled between Leo and Boötes, this constellation carries both a royal legacy and a cosmic treasure trove. Comet Berenices means Bernice's hair, and it's one of the few constellations named after a historical person. The story goes that Queen Bernice II of Egypt sacrificed her hair to the gods for her husband's safe return from battle. According to legend, the gods placed her flowing locks in the sky as a constellation. Romantic? Absolutely. But beyond a cute story lies some incredible observing. While the constellation doesn't have any stars brighter than 4th magnitude, it is a rich area for deep sky observers, especially if you like hunting for galaxies. But let's start with something you can see even without a telescope. Our first object is Melat 111, also known as the Coma star cluster, and Colander 256. Made up of around 40 stars, this is a wide, open cluster located only about 280 light-years away from us. It spans nearly 7.5 degrees across the sky, about 15 full moons side by side. It's bright at magnitude 1.8, although its stars are only between 5th and 10th magnitude. It is best seen with binoculars or a wide-field scope, where you'll see a scattering of bright white and blue stars forming a large V shape. It's a breathtaking sight and a great object to start a night of deep sky observing. While large and bright, it is best seen under dark skies to really appreciate its beauty. Now, as we know, it's galaxy season, and May is the perfect time to explore several galaxies and more, as Comet Berenices is well placed on May evenings. This constellation may be a faint constellation to the naked eye, but it's a goldmine for deep sky observers, especially if you're into galaxies. It's home to 8 Messier objects, most of which are actually members of the Virgo cluster. The first galaxy that we'll explore is M98, an edge-on spiral galaxy, roughly 44 million light-years from Earth. It glows dimly at magnitude 10.4 and spans 11 by 2.5 arc minutes, making this galaxy about 160,000 light-years wide. It was discovered by Pierre Méchain on March 15, 1781. He also discovered M99 and M100 the same night. I've been able to spot this in 11 by 70 binoculars, where it appears as a small, faint smudge of light. The galaxy looks best in a telescope. In my 8-inch SCT, the galaxy appears as a stretched-out oval that is brighter toward the center than at the edges. The center of the galaxy is much brighter and easier to see, but after continued observations, you'll be able to tease out the fainter details in the outer portions of the galaxy. Locating M98 is pretty easy. Start at Denebula in neighboring Leo and sweep 6 degrees east and you'll spot M98. Our next target is just over 1 degree east and half a degree south of M98. This is where you'll find M99, a face-on spiral galaxy about 55 million light-years away. It glows at magnitude 10.2 and spans 5.3 by 4.6 arc-minutes in size. It has an asymmetric shape, likely caused by gravitational interactions with a neighboring galaxy. In my 70mm refractor, it appears as a diffuse glow with a brighter center. I've observed it with a 10-inch scope from dark skies, and the uneven spiral arms were just barely visible. Long exposure images show the beautiful, intricate nature of this galaxy. The next object on our list is M100, one of the largest and brightest spirals in the Virgo cluster. It is located about 57.5 million light-years away and presents a classic face-on appearance, glowing at magnitude 9.5 and spanning 7.5 by 6 arc-minutes. This face-on spiral galaxy is nearly 63,000 light-years wide. In my 70mm refractor, it looks like a round, softly glowing patch. Under dark skies with my 8-inch Dob, the spiral structure is evident. It's a favorite springtime galaxy and always worth a look. To locate M100, start at Denebula and sweep 8 degrees east and 1 degree north. The next object on our tour is the lenticular galaxy M85, which is located about 60 million light-years away. The galaxy shines at magnitude 9.5 and spans 7 by 5.5 arc-minutes in size. In binoculars under a dark sky, it appears as a dim, oval-shaped glow, while in a telescope you can spot the dense core even in a modest scope. M85 is interacting with a nearby barred spiral, NGC 4394, so if your skies are dark and you're using a medium to large aperture scope, see if you can catch both galaxies. From M100, sweep north 2.5 degrees, and then sweep east 0.5 degree, and you'll spot M85. Our next object is one of the prettiest spiral galaxies visible in the spring skies. Located about 53 million light-years distant lies Messier 88, which glows at magnitude 9.6 while spanning 7 by 3.5 arc-minutes in size. Fortunately for us, the galaxy is tilted just enough to give us a great view of its structure. Through a 6-inch or larger scope under dark skies, you can begin to detect the spiral arms. Even in smaller instruments, it appears as a bright, spindle-shaped patch with a pronounced core. Finding M88 is pretty easy as well. Just sweep a little more than 10 degrees east of Denebula, and you'll be looking right at M88. Next on our tour is M91, a barred spiral galaxy located about 63 million light-years away. It's fainter than several nearby galaxies and is often overlooked, which makes it a rewarding find when you can pick it out. Glowing at magnitude 10.3 and spanning 5.4 by 4.3 arc-minutes, this galaxy is about 100,000 light-years wide. In smaller scopes, it appears as a diffuse elliptical glow. With my 8-inch Dob under a dark sky, its central bar becomes apparent, making for a unique observing experience. Locating M91 is pretty easy to do. From M88, sweep 3/4 degree east, and you'll spot M91. An easy galaxy to spot is M64, a spiral galaxy that is often called the Black Eye Galaxy. Long exposure images reveal why it gets its moniker. Glowing at magnitude 8.8, while spanning about 10 by 5 arc-minutes, this galaxy can be spotted with binoculars as a diffuse glow. While in my 8-inch Dob, the galaxy appears somewhat oval in shape, with a brightening where the core is. In larger scopes, you can begin to pick out the dark patch near the core of the galaxy. This is a fun galaxy to observe. Finding it is pretty easy as well. Start at Diadem and sweep west for 3 degrees, then north for 4 degrees, and you'll spot the Black Eye Galaxy. Okay, so maybe galaxies aren't your thing. I get it. So let's explore M53, a fine globular cluster. Discovered in 1775 by Johann Bode, this stunning cluster measures 13 arc-minutes across and glows at magnitude 7.6. It's located about 58,000 light-years away, making it one of the most distant globulars that is orbiting our Milky Way. In binoculars, it appears as a large, faint, uneven glow, but in a telescope, even a small one, you'll begin to resolve its dense core surrounded by a misty halo. With my 8-inch Dob, the core appears somewhat well resolved, and I can begin to resolve individual stars in the outer edges of the cluster. This is an often overlooked globular and well worth a look on spring evenings. Locating M53 is easy. Start at magnitude 5.2 Diadem, also known as Alpha Comet Berenices, and sweep half a degree north and 3/4 of a degree east, and you'll be looking right at M53. Our challenge object this month is a pair of interacting galaxies known as the Mice. Cataloged as NGC 4676, this is actually a pair of galaxies. These are two beautiful spiral galaxies locked in a dance of tidal interaction and are located about 290 million light-years away from us. Even at that incredible distance, the chaos of their interactions is evident. While visually in larger scopes under dark skies, they're visible as a faint stretched-out pair. But long-exposure images reveals the real drama taking place with this pair of galaxies. They get their nickname, the Mice, from the long, sweeping tidal tails trailing behind each galaxy. These tails are caused by intense gravitational interactions, or, more specifically, galactic tides. Just like how our moon creates tides on Earth due to its gravitational pull, the same principle applies with the Mice, but on a galactic scale. As these two galaxies pass close to one another, gravity pulls harder on the side that's closer, stretching stars, dust, and gas into these elegant, narrow arcs. But this is no gentle waltz. They're actually in the middle of a slow-motion collision that's been unfolding for hundreds of millions of years, and it's not over yet. The Mice have already made one pass, and will likely continue to orbit, collide, and eventually merge into a single, massive, elliptical galaxy. What makes the Mice especially fascinating is their unusual coloring. This is evident in images of it taken by the Hubble Space Telescope. The galaxy to the north, NGC 4676a, has a bright core with several dark markings, most likely dust lanes, and is surrounded by what's left of its spiral arms, which now look bluish-white. Interestingly, its long tail starts out blue, as you might expect, but then fades into a more yellowish hue near the tip. That's backwards from what we usually see. Most spiral galaxies have yellowish cores and bluish arms, since younger, hotter stars, those that burn blue, tend to form farther out in the spiral arms. This color reversal might be due to bursts of new star formation happening along the tail as material gets compressed during the interactions. The second galaxy, NGC 4676b, has a more yellowish core and a pair of faint arcs that seem to be the remnants of spiral arms. Below those arcs, you can see some bluish features as well, again, likely regions of new star formation triggered by collisions. To spot NGC 4676, you'll need at least a 10-inch scope under dark skies, as the pair is faint, glowing dimly at magnitude 14.7. The galaxies span a little more than 2 by 2 arc minutes in size. Just catching a glimpse of it will be rewarding, as this is a truly challenging target. However, it's a popular target for deep sky imagers working at long focal lengths. To find the Mice, start at magnitude 4.2 Beta Comet Berenices and sweep west for 3 degrees, and you should spot the Mice. They're visible about half a degree west of an 8th magnitude star. So whether May evenings have you sweeping the skies with binoculars or exploring with a telescope, Comet Berenices delivers. This small, often overlooked constellation packs a punch, from its roots in ancient mythology to some of the richest fields of galaxies that we can see. I hope that you'll explore these wonderful objects and that they become favorites of yours as well. Well, that's all for this episode. Thank you so much for joining us, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a text or a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy Podcast group on Facebook. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Please do all the podcast YouTube things, such as like, subscribe, comment, and share. It really helps us. If you'd like to help support the Astro Guy Podcast and YouTube channel, you can buy us a cup of coffee. The money is used to maintain and update the equipment that we use to create and publish the show. The link is in the show notes. Thank you again for joining us, and may your skies be clear. As always, Carpe Noctem, seize the night.
I'm Wayne Zool, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.